Hi everyone, let's do the next 3 laws. All right, how do we raise a power to a power? What if we have x to the second all to the third, all raised to the third power? We're raising a power to a power or exponent. Sometimes the word power is interchangeable with exponent. Sometimes a power means like x to the second. All right, well, what is the cube of anything? When you cube anything, what do? You take 3 copies of the thing and multiply them together. So the cube of x squared is x squared times x squared times x squared, right? Well, that's going to be x to the, remember, when you multiply powers of x, what do you do to the exponents? You add them. You add them. But now what is 2 plus 2 plus 2? 2 plus 2 plus 2, you can think of that as 3 times 2, or 2 times 3. 2 times 3 is 6. 2 plus 2 plus 2, or 2 times 3, that's 6. So now we have x to the 6th. When you raise a power to a power or exponent, you multiply the exponents. Here we get x to the 6th. To raise a power to a power, you multiply the exponents. Now, what if you take the power of a product? What if we have the square of x times y? Well, when you square a product, you take the product of the squares. When you raise a product to a power or exponent, you share the exponent. The square of xy ends up being x squared y squared. Why is that? Well, what's the square of anything? You take that thing and multiply it by itself. We have xy times xy. Now, because multiplication is associative, it doesn't matter how we group these things, xy, xy. Multiplication is also commutative, meaning that we can switch the y and the x, order doesn't matter, and we get x, x, y, y. So then, what do we end up with? Well, as promised, we get x to the second times y to the second. X squared, y squared. When you square a product, you square each factor. The power of a product equals the product of the powers. In other words, you share the exponent among the factors. This does not work with addition, however. All right. The power of a product is the product of the powers. You share the exponent. For the power of a quotient is a similar idea. We have the square of x over y. When you square anything, you get the thing times itself, x over y times x over y. We then multiply across. On top, x times x is x squared. And on the bottom, y times y is y squared. So kind of like with a product, when you raise a quotient to a power, you share the exponent. When you raise a fraction to an exponent, each part gets the exponent, x squared over y squared. The power of a quotient equals the quotient of powers. You share the exponent. Now you might be wondering, well, wait a minute. This is illegal if y is what number in value? Well, y cannot be 0, right? But that should be evident from this final expression, right? It should be evident here that y cannot be 0. So there is a restriction, but it's not hidden. So we don't have to write that y cannot be 0. Although if you want to, that's fine. Once again, the power of a quotient is the quotient of the powers. This over here. You share the exponent. Now again, you do not share the exponent if you're dealing with addition or subtraction. That does not work. The square of x plus y is not x squared plus y squared, but it does work for multiplication and division. Next up, we're going to look at 3 laws that may not be as obvious to you.